Hello there. 1222 11. Okay, now let's kick it, shall we? Anyway, so I wanted to make it stream just for the sake of testing the new proxy chunks workflow, as it should be real close to what we are getting while using the for loops. And so basically the new version, new 1.20 version actually provides a new way for iterating, and it's chunk based, so it's only 4 traits at this moment. And this kind of approach is certainly for those who would like to push the performance up to the limits. It's not really general purpose. Let's say it's a pretty sophisticated workflow, and you always got to be cautious when you're using it. But if you know what you're doing, it should be like really performant. And again, the normal way of operating or iterating the entities is pretty much optimized, and it's quite fast. But if you really want to um, remove all of the unnecessary checks, unnecessary for you, and you're sure, again, you're sure what you're doing, it should be close to what you're getting while using the for loops. And let's go. Let's actually test what we are getting. So we will be continuing to use our existing testing plate, let's say it like that, testing case. And what it's gonna do is basically spawn quite a bunch of subjects, and then just iterate upon them and increment and just add a velocity vector to the let's say position 1. And yeah, so if you want to dig in too close to what you're actually getting, you have to be aware of what are those standard ways of iterating are. So basically, the iterating using a cursor or iterating using the operating lambdas. And all of these workflows are essentially making, as I've said in the previous streams, those workflows are actually performing quite a bunch of tests when they are performance. So it's the testing for flags, testing for bounds, and yeah. So you may actually want to suppress them if you're absolutely sure that your subjects are not gonna change in any sophisticated way. You're not spawning or changing traits and such. So you have to make sure that your workflow is basically immutable, let's say like that. But you can actually test how, if the subject is absent, if it's stale. I will show you a bit later how to do this properly. But yeah, this is basically for the like uh, very determined state of things. So you're absolutely sure that your iteratings will be consistent within the chunks. And what are these proxy chunks exactly? Well, according to classical way of storing traits and components in the ECS pattern, they're basically stored within the chunks, or I don't know, batches, let's say it like that. So every particular trait, or let's say component, the new Unreal Engine's mass actually is using a new term, yet another term. It's called fragment. And I will talk about this mass new thing too just a bit later. And yeah, so no matter how you call it, it's basically a component that's assigned to the entity or subject in our case. And these traits are stored in a separate chunk-like manner, batch-like manner. So these are just arrays. We call them trait lines. Let's just show it on the screen. So every trait, every component is stored within its own line within the chunk. So for example, if you get like perhaps positioned trait, or maybe velocity trait, or maybe, I don't know, burning status, or I don't know, something like critical heat status, doesn't matter. These are all like stored within the same quite maybe quite massive chunk, and those are stored within the parallel lines. Let's say like in the pool, for example, where the contestants are swimming for victory along their own line. And the chunk proxies are like, they have basically the same interface as the normal chunks, so you will be able to access a certain trait or a certain subject status, certain fingerprints, certain flag mark, bunch of stuff, and those are stored within again within their own lines, but those are not really those are not physical lines. Those are basically logical lines, which in turn reference the corresponding chunks, corresponding physical chunks. So those are like intermediate buffers for the real chunks. And I've already written the code, so basically I can just write it again. Shouldn't be really hard. I don't know. I don't want to like. So this was the code before the normal operate concurrently. The current status quo for the and the standard way for iterating within apparatus. So you basically obtain the mechanism for the world that we are residing in for this mechanic. Basically, this costs almost nothing, shouldn't really be important. It's not like entity count based. It's just a single operation. It's pretty trivial. It's already cached within the apparatus, so it's not an issue. And then you basically get in the chain. So you chain all of the chunks or belts, so it's both chunk based and belt based, iterating compatible, and using the corresponding filter. So yeah, so I'm going with the vector trait here. So I'm going with the filter that matches trait, that matches subjects, that matches traits, or both with the well with the same like with the same topology, having this vector trait exactly. And then you're basically executing the operate concurrently method. That's accepting a lambda. It can most certainly accept a static function or something like that. Doesn't matter. So this is your actual mechanic, and this actually increments the internally stored vector using the just the delta time from the ticking method, a standard way of like performing animations, time-based animations in Unreal Engine, and just moving them upwards. Again, we are not really seeing any like entities. It really doesn't matter at this moment. So what we want to measure the cost of this actual construction. So this one, and how much of a footprint it has on the performance. So I will just make sure that you're actually aware of what was done before. So this is the plain array case. So it should be like the fastest way. It's not like very compatible or something like that. It's not logically intensive. So it's basically a for loop. So yeah, these things for using the plain arrays. And yeah, so it's pretty solid. We're getting like 2.5 milliseconds a frame, and currently iterating about 2 million, I guess. Let's just double check this one. We're gonna be implementing this next if that will be working using the chunk proxies. So yeah, let's just compile this stuff and double check what we've got. And by the way, yeah, you can actually ask any questions that you're struggling with or have, like maybe some, or you're puzzled with. And yeah, so it's going to close this. So yeah, and yeah. So let's just, yeah, this is exactly what I was talking about. The count is currently 2 million subjects, 2 million entities. So yeah, that's not really, let's say, not really, I don't know how to say it. That's not a real mechanic. Yeah, it's pretty trivial. It most certainly you won't be like performing such trivial stuff within your mechanics. It would be more complex, but we need to keep it simple like that, because we're basically testing the cost of the construction for the iterating, and the goal is to have it as low cost as possible, obviously. So your mechanic should basically just execute these statements per entity. You won't like to be getting like real bottlenecked here, because every mechanic will essentially be slowed down with this construction. And yeah, so these can actually operate concurrently. So the like the cost of this construction will proportionally decrease if we get in like more threads, obviously. So we'll be executing this stuff like in parallel. And if you're gonna see this in the builds, we actually have a 2x version. Of course, we are getting maybe a bit of a drawback since we're running the editor. Let's close it. Let's just close it and run the 8x version. Yeah, I got the paper planes demo here. No longer needed. So yeah, we will be getting in 8 threads. So this is actually like very parallelized currently, and we are getting about 7.2 milliseconds. Yeah, again, the cost of these like even parallel constructions is pretty much notable. And how would you actually decrease this stuff? So you just have to like minimize all of the checks done to the subjects that are performed here. Again, checks for being actually present, checks for not being stale or something, checks for the traits to be there when you execute this, because, well, we are using a solid chain. In chaining, it has a lot less checks than the normal one, but still, there are stuff that has to be checked each iteration. So, for example, the flag marks are checked every frame, including those that are actually positive and negative. So quite a bunch of stuff is actually performed here, and you just want to do this stuff. So no longer having all of these not necessary for your case checks. And let's first introduce a new variable. Let's call it maybe not the best way to design this stuff, but certainly the cheapest one. And let's call it chunk proxy. Let's call it proxy chunk. Don't remember myself. Anyways. Be like that. Doesn't really matter. We're gonna see it here. So yeah, if this flag is proxy chunk, just a minimal logic to implement the actual test. And yeah, again, you should be getting the mechanism here because this will be apparatus based. And let's go on and declare something new. And this is basically the array type that's consistent of chunks, the proxy chunks, and we're gonna declare it like that. So it's T array and it's T proxy. Why don't I get the? Let's see. How does it called? Chunk proxy, right? Yeah. So we're gonna see it. And this one is generalized using some certain types. The first one is the actual subject type that you're gonna be using while iterating within this proxy chunk. And for our solid testing scenario, we're gonna be using this solid subject handle. So let's just pass in this one here. Yeah, and the second one is an actual trait that we'll be going to iterate by, we're going to be using while iterating, and it's our vector trait, a simple vector trait, nothing particular. And yeah, so this is the type of the adapters for the chunks that we are going to be iterating using the for loops, the trivial for loops. And let's get it called like proxy chunk proxies. Yeah, and well, how do you get these proxy chunks actually, or how do you synchronize this array so you will be getting the new stuff or the actual stuff that's matching those chunks? It's pretty much the same as you would do with the normal chunks or with the normal operating. So you will be going to use the enchain method, and I'm going to mechanism and chain. We don't really need enchain solid here since we're using already solid handles. And yeah, again, we should be issuing a filter here because this thing is quite interesting actually. You can have more stuff within the filter. But if you are accessing only the certain traits within your iterating process, you just omit it from the actual chunk proxy type. So you can have less types here than the ones that are in the filter. You can actually have more type there, but it will not be that efficient. So if you're like listing a trait here, it gets an automatic and real fast remapping. And yeah, it's one of the like sophisticated performant and both and still usable features of the apparatus as compared to the Unreal Engine's current mass state. It's pretty much not that useful because you basically have to access the views separately, things like that, and you'll just write in some simple code here. Yeah, it's T filter F factor trait. Yeah, it's a constructor.